Okay, we discussed chapter 6, the normal distribution. And here is a normal distribution. Here is a picture for the normal distribution. And we need the mean and the standard deviation. And the normal distribution is symmetrical, continuous, L-shaped, right? But last time I gave you a special case. It's a name standard normal distribution. Always mean equal 0, yeah, 0 in the middle, and standard deviation equal to that. So roughly between -1 is 1 sigma, -1 sigma, +1 sigma, roughly I can say there is a 68%. And plus and minus 2 is a 95%. I can show you another picture. Yes, this one is better. It's a plus and minus 1 sigma. There is a 68%. But we can get exact probability with the 4 decimal places from the detail, right? But roughly it is a point 68. So half 34, the other half 34, because the normal distribution was symmetrical, and it's as a 95%. So this half, how much? 47.5, and the other 47.5%, and totally 95%, right? Yeah. So it is the visualize the normal distribution, but remember the standard normal distribution is a special case. The mean equals 0, and standard deviation is equal to 2. And between plus and minus 3, there is the 99.7%. So I gave you is one more wider. It's a plus and minus 4. There is almost 100%.
So it keeps going.
Yeah, we can keep going, but we don't have to. Because the less than -4, there is nothing. There's nothing. Less than -4. And even bigger than 4, nothing there. Right? So most of the probability between plus and minus 4. So we don't have to go down.
So
yeah, there is nothing.
So eventually you will touch the curve is coming down, right?
It's coming down.
It's not touching because
but it's never ever touching. But it's getting down and down and down, right? It's all, that is the reason why I describe it almost nothing. Almost 100%, right? Yeah. You know, in statistics, we are not guaranteed. Yeah, always, yeah. I'm not saying I'm sure. Yeah. My height might be 60. Lower chance. Yeah, it's almost 0%. My height is 60. Yeah. So look at this. Yeah, it is a Z table. Did you print out the Z table? Thank you, thank you. Okay. It is a page. It is one page with the positive Z-scores. The first decimal places, and the second decimal places over there. Here is the 0.00. 0.00. Always the Z table gives us left-hand side of the probability. So, 0.0 and 0. 0.0 and 0 to the left. Exactly 50%. And the Z-scores is getting bigger and bigger, right? Yeah? The probability is wants to be is getting bigger and bigger than 50%. This makes sense, right? Yeah. So when I go to the second page with the negative Z-scores, yeah, the negative Z-scores is here's a 0 and negative Z-scores to the left. All probabilities inside is smaller than 50%. Which one is the smallest z-score? The smallest z-score is the negative 3.49. Negative 3.49. How much is the probability to the left? 0.0002. How much did I tell? Did I say less than 4? Almost nothing. I told you less than 4, almost nothing. But the smallest z-score from the z-table was negative 3.49. And to the left, there is the only probability, 0.0002. But again, when I go to the right, it's getting bigger, bigger. Then the probability to the left is getting bigger and bigger and bigger. At 0, exactly 50%, and above the 50%, right, it's bigger and bigger and bigger. So I gave you a map. We had a z, which was a standard normal distribution. It was a special case. Mean was 0 and sigma was equal to 1. And we found some probabilities. Sometimes it was in the left-hand side, sometimes to the right, sometimes in the middle, right? Then we found the probability from the z-table. So it was the last topic. And the homework is tonight. Do you have any questions, problems? Yeah, if you understand how can you get the probability from the z-table, then everything is much easier, right? And remember, the z-table gives us only the left probability, only the left. So whenever we need the right probability, we have to do 1 minus. Between, we have to take 2 probabilities from the z-table and take subtraction. How? Bigger one minus the smaller one. Because any kind of probability must be positive. So take the bigger one minus the smaller one. Make positive probability. Any questions? Okay, then today, please look at this problem. How much is the mean? The mu is not equal to 0. It is 10. How much is the standard deviation? It's not equal to 1, but it is 2. So now, I have to add a normal distribution here. Today, we have a normal distribution. Any kind of normal distribution. Mean is not equal to 0, and sigma is not equal to 1. Let me see. We have only the z-table. Why it has the name the z-table? Because it is the table only for the standard normal distribution. But now, in this example, we don't have the standard normal distribution, right? What does that mean? We cannot. We can use the z-table, right? That is the problem. But if we have a breach, if we can take the z-score, then we can take the probability from the z-table. This is a good idea, right? But if, how do you think? Yes or no? Yes. Yes. We can take the z-score. Here is the way to take the z-score. In the way, we are going to take the z-score. Then now, we can take the probability from the z-table. Everywhere. To the left, to the right, even between. Good, right? Let's do it. In this example, we have a non-standard normal distribution. Mean was 10 and standard deviation equal to 2. Let me say the random variable is not a z, but it's just simply just x. Yeah, or random variable with the mean and the standard deviation. And I need the probability between 11 and 14. It's between 11 and 14. But unfortunately, the two values, 11 and 14, are not on the standard normal distribution. But they are on the normal distribution with the mean 10, standard deviation 2. What I have to do? We need the z-scores. We need the z-scores at 11 and 14. How? 11 minus the mean divided by the standard deviation. How much was the standard deviation? 2. Thank you. And we are going to take another z-score at 14 using the same way. 14 minus 10 over 2. Okay, now let me take the first one at 11. 11 minus 10, 1 over 2, positive 0.5. But always we use the 2 decimal places for any kind of z-score, right? So let me say it will be positive 0.50. Let me take the other one at 14. 14 minus 10. The difference will be 4 divided by 2. That will be exactly 2, even. 2 decimal places. Positive 2.00. So now we have 2 z-scores. It is a z1 and z2. z1 and z2. Can you give me a probability at z1 at positive 0.5 and 0? How much? Say again? No. 0.6915. Be careful. You know, 0.50. 0.50 looks like a probability, but it is not a probability. What is it? A z-score. With the z-score, we have to look for a probability from the z-table. Right? So the probability at a z-score, positive 0.5 and 0, will be 0.6915. Where it is? To the left. Can you give me another probability to the left at positive 2.00 at another z-score? 0.9772. We have 2 z-scores at 11 and at 14. We found 2 probabilities at the 2 z-scores. One was 0.6915 and the other one is the 0.9772. But we need a probability between 11 and 14. Between 2 z-scores, 0.5 and 2. How can I do? Subtract how? The 0.977. Bigger one minus the smaller one. Yes. The bigger one, 9772, minus the smaller one, 6915. So when I take the difference, 0.9772 minus 0.6915, then the difference will be 0.2857. That would be the probability between the two scores. After we got the z-scores, we did last time, and you did in the homework, right? What's the new? How can we get the z-scores from 11 and 14, right? So let me show you the map again. Yeah, here is the map. We did this one. What is the today's topic? That's it, right? Yeah. So using the formula, now we can get these scores from any kind of normal distribution. So please add a new topic. How can we get the z-score? After that, exactly same thing what we did before, right? So still, we can use the z-table to get the probabilities. Between, we have to take the difference. Any question? Sounds good, right? Okay, let me look at the formula. Yeah, the formula. I mean this one. Please look at this. This one first. I'm the normal distribution. What was the normal distribution? Mean was 10. Mean was a 10. Oh yeah. I stand on 10 here. 9, 8, 7, 11, 12, 13. So now I am 10 on the 10, right? And how much was the standard deviation? 2. You know the standard deviation is the measure of the size. It is twice bigger. It's twice bigger than the standard normal distribution because the standard normal distribution had the standard deviation equal to 1. But now I have 2. It's twice bigger. That, right? Yeah, it's big size. I'm the x here, right? Please think about minus the mean, my mean. What was my mean? 10. Now I have many values continuously. 7, 8, 9, 10, 11, 12, 13, right? But every single value minus the mean 10, minus the mean 10, minus, let me see. Now I have a 10 here in the middle, minus the mean 10. 0. Will be 0, thank you. How about the 9? Go to negative 1. 8 goes to negative 2. How about 11? Goes to 1. 12? What does it mean? Minus the mean. Just moving. Just moving and stand on 0. Negative 1 from 9. Negative 2 from 8. Positive 1 from 11. Positive 2 from 12. Right? If I have here, when I am here, maybe my mean was negative 20. Negative 20 subtract negative 20. Negative negative will be addition, right? Yeah. So when I was negative 20, right? And minus my mean myself is again is moved to here and settle down where? 0. Right? So when I take a difference with my mean, wherever I was, right? Is it here, there, wherever? And just move and stand on 0, right? But what's the problem? Still I'm fat. Yeah, same shape. Yeah, it's fat. Additionally, take the division by sigma. You know what's this? Divided by the standard deviation. It's actually it is a diet. I move to here. Still I'm fat, but I get diet. Then what will be my shape? My shape will be standard shape. Who will be the standard normal distribution? Right? So simply, yeah, it is easy. It is easy to get the z-score. Just to take off the mean divided by the standard deviation. But please try to understand why we have to take off the mean. It's a relocation, right? Why we have to divide it by the sigma? Because we have to make the standard shape of the distribution, the standard normal distribution. Yes.
You said this table only gives flat probability.
Yes.
At first I was understanding you have a z number, right?
A z number.
And then I have right and I have left. So
Okay.
why are you saying that it only?
Sometimes we need a probability less than left hand side. Sometimes we need a probability is greater than right hand side. It depends on where do we need the probability. Sometimes we need a probability between A and B. Then we have to get the two z-scores, two probabilities. Subtraction will be the probability between. Yeah. So please remember the map. Right? And please try to understand why we have to get the z-score in that way. Yeah, relocation, and we have to make standard normal distribution.
Right.
Say again?
When you look at the other one, you're moving to the right.
This one?
Yeah, when you take that.
Yes, from here to here to get the z-score. And then moving to the right again, one step more to get the probability from the z table. Yes, we have the two steps. Get the z, one step, get the probability, second step. Okay? Yeah. So now, let me copy the map again. Here's the normal distribution. And we got the z. And we found the probability from the z table. And here is the formula. Take off the mean divided by the standard deviation and take the z table. Okay. So far so good? And now please look at the example number 8. Yeah, it is long example. Yeah, please read it. Last one. Second, last one. Did you read it? Okay, let me see. What do you mean? I think the last sentence is the question, right? So let me focus on the question here. How long can be the guarantee period? Guarantee period. See? We found probabilities. We found probabilities from the standard normal distribution. But today, from any kind of normal distribution, we found the probabilities, right? The guarantee period is a probability. Is it a probability? No, it is not a probability, right? So the guarantee period is not here. Then where? Is the Z? No. Now you need the answer, right? Not the probability, not the Z score. Then where is the guarantee period? Here, right? So let me say X here, which is the guarantee period. Now here, we need the guarantee period, right? Before, we started from here to get the probability. But now, our final destination, the final goal is this. From where? From a given probability. From here. So now, in this example, we have to go to reverse way. We need find a value x from a given probability. Inverse, the reverse way. Okay? So can you see a probability? Any probability? What would be the probability then? 7%, yes. The 7% must be a given probability. So I have to plug 7%. It will be 0.07. And now what? We need the guarantee period. It's X over there, right? Before, when we had a normal distribution, and we went to the right, in the middle, just stop by to get the Z-score. And then we found the probabilities from the Z table, right? Now I have to go home, right? From a given probability, get the grace period is over there, is left end. Yeah, keep going to the left. In the middle, you have to take the Z-score. And then
find 0.7 on the table and we just find the score of that?
Yes, I will. And then we are going to take the X score in the left hand. Do you have an idea, right? Yeah. So now we have 7%, and we are going to get the Z score from where? Where do you expect from? From the Z table. Okay. Yes. Why not? So just a second. Let me make the normal distribution as a normal distribution. Now I have a normal distribution. The X must be the lifetime of the game. Do you know how much was the average lifetime? 30 months, right? And also, did you have a standard deviation? 4 months. It's a 30 months and 4 months. Okay. And now we have a 7%. A probability was given. You know the probability 7%, we have to plug into the left end or the right end. Which one? Left? Let me try plug in the right hand side, right? So let me try to plug 7%, you know, the 0.07 as to the right, right? Then here must be the guarantee period. You know, the most of the expensive item has the warranty, right? Yeah. We knew the item, the game, lasts longer 30 months on average. If I give the customers warranty 40 months, 50 months,
You're gonna lose a lot of money.
it's not a good idea, right? Yeah. You know, see, when you buy a car, most of the manufacturers is guaranteed, is warranted 3 years. What does that mean? They knew it. No problem in 3 years. 5 years warranty, they knew it. It's no problem in 5 years, right? Because they have to make the money. Yeah. So 7% is plugged into the right. It is not a good idea, right? The warranty must be there. Does it make sense, right? Yeah. So let me erase it. Let me erase. And the 7% and the guarantee period is must be here. The guarantee period. And I have to plug 0.07 there. Okay, good, right? So the probability 0.07 was given. And what do we need now? We had a probability, and now I need a z-score. I need a z-score here. Do you expect a negative or positive?
Negative.
Okay, 50-50. Negative or positive?
It's going to the right, so positive. But it's below.
Just a second. Where is the value in the middle on the standard normal distribution? Zero. Thank you. Zero here, right? We need a z-score in the left. Now, again, negative, still positive. It must be negative. The z-score must be negative because the z on the standard normal distribution mean was 0. Negative, positive. So we need a negative z-score. Because why we need the negative positive z-score? Because we have 2 pages of the z-table. Now we have to go to the negative z-score table.
I'm confused how you determine how it got on the left side instead of the right.
Okay, the grace period is kind of the warranty. But I knew it lasts 30 months on average. The warranty must be less than 30. Does it make sense? Right? Yeah, we can make the money. Good, right? It's not here, but there. Yeah.
So you're gonna put minus 0.07.
0.07 is a probability. Never ever negative. Let me go to the z table. Let me go to the z table.
You put a negative in this case. You're looking at the negative z table right now. That's all it's saying. Then you gotta find
Yeah.
I have to have
Here is just a second. Here is the negative z-score. We have to pick one of them. The negative z-score. How much was the probability? The blue area? 0.07, right? So inside of the z-table, there are the probabilities. So in the middle of the z-table, I have to look for the probability 0.07. 0.07. 0.07 here. Unfortunately, we cannot find exact probability 0.07. So probably the probability 0.07 is must be these two probabilities. The left one is a 0.0708, a little bit bigger. Right one, 0.0694, a little bit smaller. We have to take either one, closer one. When I take the difference with the 0.07, the difference will be 0.0008. How much will be the difference? 0.0006. Which one is closer? This one is closer. The probability 0.0694 is close to the probability 0.07. But what do I need?
0.07.
I need a z-score. I need a z-score. The z-score will be negative 1.48. Exactly reverse way. You know, before we had a z-score, negative 1.48, and we found the probability. But today, now, we have a given probability.
So,
and we have to look for a z-score negative 1.48. Guess what?
I had used the 0.07.
0.07, yes, here.
But I didn't go, I went to the positive. But we're not going to the positive one. I know.
Probably you went to.
But if we had.
Probably you went to 0.07.
So I used 0.
Be careful. 0.07. This 0.07 is not a probability. Then who is that?
My z.
Your z. Yes, your z. But now, what do we need? We need a z from a given probability.
So, wouldn't be the 0.5279? No. 0.5279 would be the probability of that z.
See, now we have a z-score. Oops. And here is a probability. Probability. Whatever. You have to figure out 0.07 could be a z-score. But now the 0.07 is not a z-score, but the probability. And we have to get z-score before, which was negative 1.48. Right? So be careful. Yeah, we have two things. So we have to go back to here. Now I have a z-score, negative 1.48. Yeah, you need more practice. Yeah, but be careful. Which one is the probability and which one is the z-score? Remember, z-score probability never ever negative.
Yeah, and that
cannot be bigger than 1. Guess what?
If we have a percent given in our word problem, is it typically a probability over?
Yes. Okay. Yes. But sometimes it's not always clearly percentages. That would be the probability. With a probability, we need the z-score, right? Yeah.
So a percentage will never be a z, right?
Say again?
A percentage will
Never.
Be a z.
No.
Okay.
Yeah. Okay, let's go home. Yeah, cross the river again, right? When I get into here to the right, we use the formula, right? Now we have another one. It's another formula. It will be x will be take the mean addition z times the sigma.
You just reverse
Yes.
the formula that you already had.
Yes. Yes, it is. Yeah, I will explain to you Friday. Yeah, it is the same thing. So now we have to apply this formula to get the guarantee period. So let me try. Next page. Yep, here. What was it? X was take the mean addition the z times the sigma. So now, what? 30 addition negative 1.48 times the standard deviation 40. It will be 30 addition minus 1.48 times 4, then it will be 24.08 months. Here is the 24.08. Yeah, we can guarantee it's about 2 years, 24 months. If you want, get only 7% refund, then we can guarantee it's only 2 years. It's a 24 month. Okay, we are going to keep going on Friday, and here is the quiz number 11.
What does that squiggly line mean? What does the squiggly line mean?
What do you mean?
Let X, whatever.
X is a random variable, and the random variable has the normal distribution. The first one is the mean, 10, and the second one is the standard deviation 4.
She's approximately.
Okay.
What is approximately?
The squiggle. The squiggle line
Between X and N, there is a little sign up
Very
there.
top,
Let
let
X all the way to the
very
top.
top.
Oh, this means?
Yeah.
Oh, I'm so sorry. It means the random variable has the random variable X has the normal distribution, the mean, the mu, I mean, 10, and sigma equal to.
Okay.
Do you know what is the name of this letter?
Yes.
What is the name of the letter?
Minya, something like that.
I have no idea. Yeah. Give me the Z-score. Guess what? Looks good? Yeah, looks good. No, you have to switch. 8 minus 10.
Oh, okay.
Let me try the very first one, part A. Part A, in this quiz, we have a normal distribution for X, mean equal 10, and standard deviation equal to 4. Part A, I need a probability less than 8. What do I need then? First, I need a Z-score at 8. How? 8 minus 10 over 4. Anybody who got the Z? The Z-score? Say again? Negative 0.50. Thank you. And also, did you get the probability? Anybody who got the probability from the Z table?
0.0 or
Where it is, you are right. Where it is, always to the left. How do you think? Is this the answer in part A? Yes. Anybody who got the z-score in part B? Another z-score in part B? Anybody? Part B, z-score?
I got 0.75.
0 positive, positive 0.75 in part B. And also, did you get the probability at positive 0.75?
Yeah, 0.7734.
Thank you. Do we have to get 1 minus in part B? No, why not? Less than, left hand side.
But C, you do have to write.
C and D is greater than to the right. So we have to do 1 minus the probability from the Z table in part C and D. E and F, take the 2 z-scores and looking for 2 probabilities and subtraction. You know, it is not, it's somehow it's a very easy problems, right? But yeah, it is your first time to get the probability from the Z table, from the standard normal distribution and any kind of normal distribution. So we need more practice, more practice, more practice. Yeah, trust me, it is not the hard problem. Right? So please do more practice and more practice. Did I say we have a second exam on next Friday?
Not this Friday. Oh,
Not this Friday.